So indeed, let's now talk about the last type of sensors. These are the capacitive sensors. And basically what capacitive sensors do is that they convert a physical signal or physical property into an electrical signal using capacitance as a mechanism. Here you see the general principle of how this happens. Basically, you have typically two electrodes. One is fixed, one is movable. A movement of this electrode will mean that you get a change in capacitance. And you can use that, for example, if you put a certain voltage over this and you will move this distance, you change the capacitance and you will force charges to move to the plate or to move away from the plate. You can detect that movement of charges by an operational amplifier and by amplifying the signal. The amount of charge that you move from such a capacitance is actually very, very small. So to be able to have any useful signal, you have to do an in situ amplification. You cannot take this view charges and try to, for example, use a wire bonder and take them off the MEMS chip and to another amplifier, because the parasitic capacitances of any wires or any structure around will be totally dominating the small changes that you actually generate in your sensor. So you have to build your sensor in direct connection with the CMOS circuitry to do the amplification. So this can be very sensitive, but on the other hand, you must have the on-chip electronics integrated. Here you see an example of such structure. Typically, this is how an accelerometer looks like. Well, similarly, how an accelerometer looks like that is in your mobile telephone today. It consists of a suspended mass with combs. In this case, you have two combs, and if the mass moves to the left, of course, the capacitance here increases. If it moves to the right, the capacitance here increases. So you can actually measure directly the acceleration and the acceleration rate by measuring the capacitance of these two capacitors.